Eddie. Good morning, good afternoon, good evening to wherever you may be. As Eddie had mentioned, I'll be showing you the pocket recognition and the SolidWorks Hole Wizard Recognition and the machining with the enhancements that we've also added in 2016. And I'll also try to go a little more in depth as far as working with it, how we can manipulate it exactly the way we want it to work, making also your everyday working with these features a lot easier and a lot more productive as well. So let's start off actually with the webinar. Let me just get rid of that. Okay. Also, there may be certain points where I may deviate a little bit from the webinar, from the actual topic of the webinar, and show you some other stuff as I'm going along. Okay, let me just first start off with the simple part that we have on our screen. If we take a closer look at the part itself, many of you may have seen this part, but I'll just go through it just in case. We have all different types of pockets over here. We have open pockets over here. We have these surfaces over here as well, which is open pocket or open on almost all sides except for that one wall. We have through pockets as shown over here, as well as these closed slots and through pockets over here as well, and these very narrow slots here also. So one more point I'd also like to bring out is that the depth of this part, the actual height from the top to the bottom of this part, is a total of 80 millimeters. Okay, I'm going to start my pocket recognition. And again, as usual, I'll go into my geometry and create my geometry. And without any special enhancements over here, the only thing I'm going to change is the minimum diameter, as I don't want it to pick up anything, any kind of diameter that's smaller than 20 millimeters, this one over here. I don't want to choose that as any kind of a geometry. So now as I click the part, it's going to check the entire part and give me all of the geometries needed, including the through pockets. And for example, as we'll see in a moment, this hole that we have in the middle will also be chosen because that hole is larger than 20 millimeters. However, the rest of these holes were not chosen. Okay, now that we've chosen our geometry, let me just go into modify geometry for a moment. Excuse me. So we'll go into modify because it chose every single surface over here. Now the top surface I don't want to do, so I'm just going to, at this point, exclude the top faces. And that automatically takes up any area that's considered a top face. And I'll accept that. Now, there are no fillets in this part. I'll get into the fillets on a different part with everyone. I'm just going to leave everything the way it is. The only thing I'm going to add here also is that where I have a through pocket, I want it to go past the bottom of the through pocket, say by 1 millimeter. Okay. Now we're all set. Okay, just one moment. Sorry, my mistake. A little freeze on my keyboard. Okay. I hope it's not my computer that froze up. Okay, just one moment, please, everybody. And let me just fix this little issue. Okay. Let me see this. Just one moment. Okay. There we go. Okay, I'm just going to restart my system. Sorry for the little delay. That happens, especially when I'm working with a little version. Okay. I'm going to restart my part. By the way, in general, I just want everyone knows that if you see over here on top, I like to keep my icons open over here. It makes it a lot easier for me to navigate in SolidWorks instead of me going to Tools, SolidCAM, and Open. I have my navigator over here as well, which I just do that by right-clicking and opening up SolidCAM, and I see everything here. Okay, I'm going to go to Browse for Recent Parts, and I'm going to choose that part over there. Okay, we'll do this again. Okay, we'll start my, I'll go to my pocket recognition. Again, create my geometry. Minimum diameter over here. Click on the part. And yes, all the parts will be available to everyone at the end of the webinar through a download link that I'll give to Eddie together with the recorded webinar. Okay, I'll click on OK. We'll go to Modify. Let me just get rid of the top over there. Okay, now let me go to my tool. I'm going to start off using a 25mm end mill, but note right now this particular tool is outside of my holder by 55mm. Okay, so if I'm outside of the hole of 55mm, previously in previous versions of SolidCAM, you were not able to use this tool in pocket recognition on a part such as this, because the depth that you would go was always constituted exactly by the depth of the deepest pocket, and you had no control as far as a maximum depth. So you always had to use a tool that was long enough to deal with this entire part. But what we've done now in 2016, if I go into my levels, we've added the option of being able to limit our lower level. So in this particular case, I'm going to click on the checkbox, and I'm going to limit my lower level. I can choose it from the part if I want, okay? Or I can actually write in the value. I'm going to write in the value of my depth of, I think, is 55mm. I'm just going to leave it to -45, okay? My technology is the same as any pocket operation that we have. Sorry, I wrote minus twice over there, -45. Technology, I'm just going to my open pocket. I like to use my strategies as shown over here. My links, everything will be exactly the way I want it to go. And I clicked on calculate, and we can simulate. And as you can see right now, it's going to go down only, I use Solid Verify for this, it's only going to go down to -45mm. So it's not going to go past that depth. So this way we were able to use a shorter end mill than we had before. Now for my next operation, since I still have to complete that, so I'll do now a save and copy. And now obviously I'm going to change it to a end mill that can go further down. Okay, this one is sticking out of the holder by a total of 80mm. And my levels, this time I'll have my upper level at -45, and I'll just get rid of the check mark for my lower level. So this way it'll automatically go down to the very bottom, and we'll click on Save and Calculate. run my simulation. Again, solid verify. And as you can see, this time it completed where it had to work. No, it did not work on the upper level, just from minus 45 on down. Okay. Now, if I were to get rid of this check mark over here, you can see also in your toolpath exactly where it's working, continuing down exactly from where it left off previously. Now, what didn't we do yet? We still have these areas to deal with. These areas are these small slots that obviously cannot be used with a 25mm end mill, as well as some of these corners. So we're going to do a save and copy, and my tool, I'm going to change that to a 6mm end mill. I'm going to leave my levels now. The top level is going to be from the very top. In my technology, I'm going to use the rest option, and my previous tool diameter is going to be 25mm. I'll just do a quick save and calculate. And if I run my simulation, you'll see that it'll only work in those particular areas where it needs to work, finishing off these slots over here and these corners over there as well. Okay, I'm going to load in a moment another part because I want to talk a little bit more about pockets with fillets as well. But before I do that, I'm going to deviate a little bit from the topic of the subject of this particular webinar. I just want to show you one thing. One thing I still want to do with this part is put on the chamfer, break all the edges on the part over here. But you'll note that in this particular case, this edge over here is a fillet over here. So I don't want to put a chamfer on this edge. So if I were to go now into my chamfer recognition, and this is new in 2016, and I create and I choose my geometry, I can have my minimum diameter again at 20, but we have here a new option called Ignore Edges Followed by Fillets. So if I click on that and now click on the part, it's going to recognize all of the edges that I need. But you'll note what it doesn't do. It does not choose this edge. Where I had the fillet, that edge is now being ignored. So it will not create a chamfer in a place where I do not need that chamfer. Okay. That's what I said. That's the little deviation I want to do from this webinar. Okay, I'll choose obviously my chamfer end mill. And levels, I'll just give it chamfer depth, let's say let's say 0.3 millimeters. Technology, link, whichever way I want to work with my link. Also my safety offset, let's say 0.5 millimeter offset from the walls. And if I run my simulation now, you'll see that it put the edge wherever it needs to, and it did not put an edge over here where we had the fillet. Okay, now let's get back to the subject of our that we originally started talking about, pocket recognition. Now I want to show exactly how we work with pocket recognition when it comes to fillet. So I'll load another part that I have over here. Okay, if we take a look at this particular part, you'll note that we have these surfaces over here, as well as over here, that have fillets on them. Okay, you can see we have a fillet over here and over here, but not only do they have fillets, the fillets are of different sizes. Okay, so if I were to click, for example, on this fillet, you can see that this fillet, it has a 1 millimeter radius. This one over here has a 2 millimeter radius. If I went into this fillet over here, you see that's also a 2 millimeter radius. This one over here is 3 millimeters. So we have fillets with different radiuses. So the way we can work with that with pocket recognition is as follows. Let's go into pocket recognition, and we'll go into creating our geometry. I'm going to have right now my minimum diameter. I don't want to go into these areas over there at all. I just want to work on these pockets over here. One more point, I want to just stop for a moment. Just want to mention something about our selection mode. Note we have selection mode for solid body and face. Remember the issue of face for now. Put that in the back of your mind. So I want to talk about that in a few moments as well. Okay, back to solid body. Let me just click on the part itself. I recognize all the edges that I want, all the faces. You can see that. Okay. In this particular case, I want to go now into my modified. Now, the first thing, exclude top faces, because I don't want to do the top face. Now let's talk about the fillets. We have a section here for fillet. Now, when I create when I look at a fillet and working with it with a regular end mill, obviously we don't want the corner of the end mill to machine the fillet. So we want we want it to actually have a little step over here. This way protecting the fillet itself. Okay? So we have here the issue of divide floor fillets by steps. Now, there's something here called number of steps. If I were to click on that, first of all, it's automatically recognized that my maximum fillet radius is 3 millimeters. It recognizes that from the part. We automatically see that. Now, it's automatically going to do it. The way I have it right now is that anything between 0 and 3 millimeters, it's going to do this having one step over that radius. Now, what I don't like about a step on a 3 millimeter radius is that it leaves too much material. And what we like to do in many cases is to actually break it down into more steps. But since I have different fillet sizes, I don't have to, let's say I want to break this down into a total of 4 steps. But my 1 millimeter radius, I don't want to break down to 4 steps. So what I can do is I can do the following. I can open up more fields, and the moment I click on the second field, it'll take the first one, divide it in 2, and then the second one will start from 1.5 to 3 millimeters, and I can say from 1 step down to 2 steps, or change these numbers as well. I can add another one, and then it took whatever between 1.5 and 3, broke that in half, and then made a step down for our next area over here. Okay, obviously these numbers can be changed. If I was to say change my maximum radius to say 1.2 millimeters, you'll note that my minimum radius for my next step is automatically changed as well. Okay, I'll just leave it exactly the way it is, but I want to have my number of steps for my small radiuses to be a total of 2 steps. My next size radius is 3, and my next size radius after that, a total of 4 steps. Now click on OK. We'll accept that. My tool, I'm going to use my 12 millimeter end mill, which has no radius in the corner, and it's a sharp corner. My levels will be the same. I'm not making any changes here. My technology, just my open, I like to use the open pocket area wherever I can. And we'll click on Save and Calculate. Now, let's take a look at the actual simulation of the part using Solid Verify. What you'll see is as follows. Okay, let's take a look at where we had that 1 millimeter radius. Okay, I'll zoom in. Whoops, sorry. And as you can see, we have 1, 2 steps. 1, 2 steps. where we had our 2 millimeter radius, we have 1, 2, 3 steps. And if I were to go into this area over here where we had a 3 millimeter radius, you'll see we have 1, 2, 3, 4 steps. So we have complete control for each radius size, how many steps we want to break it down to. Okay, now let's continue. And what I'd like to do is now actually machine those fillets. When I machine those fillets, I'm going to be using an end mill that actually has the radius that I need for that fillet on it. So I'm going to do save and copy. Let me get rid of this check mark over here. And let me first go into my geometry. And I want to go into modify. Okay. Now, one moment, please. Let me just make this a little quiet over here. There we go. Now, let's first deal with this particular radius over here. My 2 millimeter radius. Okay. So what I'm going to do is I'm going to get rid of what I don't need, or I can uncheck all and say, okay, let's work on I want to work only on this and this. So I can pick it on the particular faces that I want to work on. Okay. That one over there and that one over there. Only those two faces. And what I'm going to do now as far as my fillet is I'm going to say ignore floor fillets, because now I want the tool to go to the wall itself. I'll accept that. I'm going to choose my tool. This time I'm going to choose a end mill that has a 2 millimeter radius on it. Okay? I'm going to keep everything the way it is right now. Just to save and calculate. One more thing. Sorry, my mistake. In my technology, I'm going to have my rest material go on rest, and I'm going to have it work around the profile. That's where I want to work, around the profile. Okay, previous diameter, I'm just going to put in here 12. And it's only working in those areas, and this time it's going to complete the radius over there. If I run my solid verify, it actually completed those corners over there. Okay, because now we told it to ignore the fillets, so it's giving us the radius of that particular tool that we used over there. And I do the same thing for the rest of these pockets over here. This one over here as well, just using a different end mill. Now what I'd like to do is load another pocket part. Okay. The part I'm going to use is something like this. This part has multiple sides on it. Okay? In other words, I'm going to be using pocket recognition, not just on this side, but I also want to work on this side here as well as this side. So if I were to go first of all into my coordinate system, you can see I have different home positions for wherever I want to work. Over here, and over here. Okay. Now, I've already created the operation, so I'll just show it to you for the moment. If I were to go into my first pocket recognition operation over here that I did, I'm going to open it up. You'll note the following. I have my Mac System 1 and my geometry as shown over here. Okay? Therefore, it's going to work on everything on this side, just like I did in previous operations over there. My technology, I have open pocket strategy. All of this is all checked exactly the way I wanted to. Now I'm going to go into this operation, you'll note that in my geometry, I'm working Mach 1 position 2. If I were to show my geometry in this particular case, I didn't choose the entire part. I just chose one particular face. What I showed you before for using face geometry, so I chose the face instead of choosing the whole part. So I don't have to mill this area over here or anything else. I just want to mill this face over there. And I'm going to talk about face geometry in a few moments also, because there's something else I wanted to point out over there. Again, using my tools, if I run my simulation over here, and let me just do my solid verify, you'll see that it does exactly what I wanted to do, machining out that side over there. Okay. And the way I did it on my third side, exactly the same thing. I created a new operation for that side, new home position, and the exact same type of operation that I did before. Okay, now what I'd like to do is I want to talk a little bit more about the face geometry. And for that, I'm going to load one more part for this particular area of the webinar on pocket recognition. I'd like to machine this pocket over here, only that pocket. Now, this is also one of the reasons what I'm showing you now is why I prefer, in this particular case, is to use pocket recognition and not our regular pocket operation. The reason is as follows. If I were to use my regular pocket operation, okay, I'm going to go to pocket, and when I create my geometry, I have to do the following. First, I'll go to create my geometry. I'm going to choose my outside chain. As you see, it chose it. And now I have to go back and choose what's open. Now I have to mark my open edges. So there's a lot more work involved over here. I have to choose this as my open edge. I have to go and click on this as my open edge, that one over there, this one over here as well, that one, and this one over here, except that. And then I have to create another geometry. I have to create a geometry for this edge over here, and I have to create another geometry for this edge over there. Now, obviously, the tool path will be the correct tool path. I'm going to use right now just the regular 10mm end mill. My levels, since I chose my geometry over there, I have my levels already done, and my open pocket strategy, which I have over here. Okay, save and calculate, and it created a tool path, and you can see it's doing it fine. But you saw how much work I needed to do in order to create a geometry for the pocket, for a simple pocket. And it's only because of the open edges. Now what I'm going to do is I'm going to delete that operation. And this time I'm going to do the exact same thing using pocket recognition. When I use the pocket recognition, when I create my geometry, all I'm going to do is click on face. When I click on this particular face over here, it's going to recognize that face, and it automatically recognizes what edges are open, what's closed. It recognizes that I have these stubs over here, and it'll also know that with these areas where my holes are, to continue on as if there's no hole over there. In other words, go straight over it. Okay? Again, I'll use my 10mm end mill. Okay, my technology, my open pocket I have already set that way. And you can see that everything is done. So choosing my geometry using the pocket recognition faces just for one pocket, especially when you have open pockets and multiple holes and studs on the part, comes out to be a lot quicker way for choosing your pocket geometry. Now you may ask, okay, in my regular pocket operation, I could have done the following also. I could have gone and say, okay, you know what? Choose my pocket, go to my coordinate system. My pocket, and I can go into multi-chain. But if I do multi-chain and click on this, what's going to happen is it also recognizes the holes as chains also. And I have to delete the holes. No, there's a lot of work that has to be done even if I do that. Not only that, but also my open edges, I still have to mark as open edges. So working with the geometry option of pocket recognition for your regular pockets makes it a lot quicker and a lot easier. Okay, since I'm already on this part, let me continue with this part and now start showing you some of the features that we have now in Hole Wizard. Okay, now I want to remind everyone, Hole Wizard process in SolidCAM works on holes that were created in SolidWorks using the Hole Wizard of SolidWorks. If I were to just take a quick look at my part itself, you'll note that we have holes. All of this was created by the Hole Wizard. You can see the Hole Wizard sign. You can see the actual size of that hole, what type of hole it is. All of this was created. We're not talking about a sketch that you may have made on top and drew a hole through it and drawn a hole through it. We're talking about everything that was created using the Hole Wizard for counterboards, for tapped holes, for simple holes. All of this is what we're talking about now. Okay, so let's start our Hole Wizard process. Now, before I do that also, I want you to take a look at my VMID. If I were to open that up, as we know, the Hole Wizard process is based on a machining process. Now, when working with machining process, the machining process has to be for that particular type of machine, because different machines have different drill cycles. So therefore, the processes have to be created for those, for each particular machine. Now, I've created the processes already, but I want to make sure that this process, that this VMID is using that process that I created. To make sure that it goes directly to this process, in my working style, we have Hole Wizard. The Hole Wizard shows you exactly which process it's going to be using. If I were to open that up, you can see I have several different processes here. I wanted to go directly to that process. Okay, I'm going to close this. Where are the processes, by the way? If I were to go into my SolidCAM part settings, CAM settings, you'll note that if I go to my machine process and Hole Wizard process, you can see that the user directory for my Hole Wizard process is in a specific area where I have only Hole Wizards over there. Okay? Hole Wizard processes is over there. Okay, so now let's continue with the actual option of Hole Wizard process. And you'll note some new options the moment I open this up as well. The moment I click on this, first of all, you'll note my interface is a little different now. You can see, first, it says exactly the tapped holes like it did before. You can also see the description as far as what each one will be doing. And one more note. You can see the database on top. Okay? It brought me the default database that I have for this particular part. If I didn't have a default, it would bring me the system's default, which is the one that's installed in the program itself. What I can also do here is I can choose a different process if I want. If I made a different process also for this VMID, but I want to have changes in here, I can use a different process. And as far as changes go, we'll show that in a few moments as well. Okay, one other note. I've added also we've added also in our Hole Wizards page a little pin over here to keep this open. Note I have several different holes I want to use my process on. So every single time I create the process, I don't want to have to go back and open it up again. I'm just going to leave this open by clicking on the pin. So let me do my tapped holes, for example. If I clicked on tapped holes, I'm going to click on the tapped hole, and as you note, it's recognizing all of that particular tapped hole on that level. I'm going to click on OK. It created the operation, and it's keeping this open. So I can go directly back and choose another one, another tapped hole over here. Choose those over there as well. Click on that. It's creating more operations and brings this window back. I want to do now my counter bore holes. No problem. Go to counter bore holes. Click on my counter bore hole over here. And it will do that as well. As we see, I will see in a moment. Excuse me. Again, keeping this open. This time, I want to go to my simple hole over here. I have a simple hole on this side. I can get rid of this if I don't want it. If I get rid of the pin, I go now to my simple hole. I'll click on my simple hole over here. It did that one simple hole. Note, it didn't open up my Hole Wizard. It didn't keep my Hole Wizard open because I got rid of the pin. I can re-click on it, obviously. Again, click on simple holes and pick on this one. But if I would have kept the pin open over there, I wouldn't have had to go ahead and click on my Hole Wizard process again. And as you can see, all of the processes were done. Now, I'd like to talk a little bit now about editing the processes and creating more processes. Now, we've created an area to be able to process our Hole Wizard processes, and I strongly advise us to use that area only. I can go over here to my machining process and edit it over here. But note, when I'm using a machining process, a Hole Wizard process, what happens in the background is that it takes the one I'm using, it makes a copy of it in the background. So if there are any editing that I've done or any changes that were done, for example, sometimes what happens is I may use a process that's not for this particular machine, for a different VMID, okay? And the drill holes may come out to be suppressed because those options are not available for this particular VMID, and it'll come out suppressed. What actually happens is in the machine process itself, they're also suppressed. But I don't want to keep that suppressed for this particular machining process. The moment I close my part, the copied machining process comes back into effect, eliminating the one that I used before. So I'm back to my original one where nothing is suppressed in exactly the way it was. So nothing is ruined inside my Hole Wizard processes. So where do we make the changes, okay, if we want to make changes? First of all, I can do the following. If I want, I can go to my, let's say I want to make changes in this one, or make a new one like this, okay? If I were to right-click over here, I'm going to save this machining process. I'm going to call this machining process web, okay? And I'm going to make changes in that particular process. Now the question is, where do I make those changes? Let's close the part itself. And if I go into Tools, SolidCAM, we have here Hole Wizard Machining Processes, open. And it'll open my machining processes that are in the Hole Wizard location. I'm going to choose the one I just created, Hole Wizard Process, Metric G3 Mail, Web. Okay? I'm going to open that process. Now, let's take a look what we have here. First of all, you'll note that each one of these processes, we've added the option of type. Okay? What adding the type does when using the process is that in certain parameters that are not for the simple holes will be grayed out, so you don't take those accidentally when creating a process. Now, one thing we've also done here is we've added the option of being able to choose a particular process and say make a copy of it. So now I have a process that's copied into here. I can make changes, obviously, in the name. For example, I want to make a one for count the boreholes, but change the technology that I'm using. So I have a different technology. Sometimes, let's say, I want to have a helical approach inside my pocket of the counter bore, and sometimes I want to do a regular pocket operation, or a profile operation, whichever way I want to work. So I'm going to change and make another copy and say, call this DEP, depth, okay? Or whatever. Now, if I were to go, I can go ahead and edit this. And for example, I can go to my counterbore profile operation, edit that, and say, okay, instead of in my technology, instead of using the depth type of helical, I'm going to use a depth type of constant. Okay, and then I can change my if I go into my levels, if I go into my technology over here, we have our finish step down. Okay, I can change my parameter over here, and I can say, okay, this parameter, I'm going to call it something else. I'm going to call it C-bore step down. Okay, so I can make changes that I want over here. I can say, okay, you know what, let's do a rough cut also as well. And over here also, I'll put in that new geometry, that newer parameter that I just created. Okay, user-defined parameters. Where was that one? Here we go. Seaboard depth. Okay. Sorry, seaboard. Okay, whatever. Here we go. Helical step down. Here we go. See, all the way down at the bottom. Here we go. Try to always add itself down to the very bottom. Okay, so I have now a new parameter over here. I'll do save and exit. And I can go to that one and give it whatever value I want for that parameter. That parameter now, which I have at the very bottom, I can say, okay, you know what? I want to use my user parameter, let's say end mill diameter divided by 2. Okay? Divided by 2. So I have now that value for that parameter. I can also go back into my operation, for example, and change my link. Say I want to have my lead in as an arc. We've added, by the way, the option in radius to use a percentage of the radius of the tool instead of a value as well. That's in general. I can also say start from the center of the circle diameter, so it goes down directly in the center. Save, exit, exit, make saves, change anything I've done over here, and exit. Now, yeah, okay. Yes, I saved it. If I go now, I'm going to load this particular part that I have over here, different part. Again, right now it's using this particular Hole Wizard. However, if I go over here, and I can change now to that one I just created, and you'll see in my list now, I have another Hole Wizard process. So I've created another hole. In other words, I can expand and have many more Hole Wizard processes, as many as I want. I can go ahead and use this, okay? And I'll have a different geometry, a different technology for this particular one. I can have it for different technologies. I can have it for different feeds and speed rates, for aluminum, for different cycle types. All of these, I can have different type, add more and more processes within the Hole Wizard, so I can have more than just that. You can notice also in this particular case, if I were to open up this process, you'll see that it has my technology as constant with my step down, okay? Everything is exactly the way I want it over here. So we've made it a lot easier now to use your machine, your Hole Wizard processes, nodes to make any kind of, I should say, more flexible. So you can actually add more processes as well. And you can also make changes. It's a lot easier. And we also made a little more of protection in the processes. Now, just one more thing, what do I mean by protection in the processes itself? If I were to open up the process that I just edited, okay? Take let's say, for example, countersink holes. I'm going to open that up. If I were to go into, say, a particular type of Hole Wizard parameter, okay? You'll note that we have Hole Wizard parameters that are grayed out. These are grayed out because in this particular type of process, for this particular type of hole, it does not have anything that's a counterbore diameter, because this is not that type of hole. So you won't by accidentally choose a parameter that's not meant for this type of hole. Since I have marked this as countersink holes, it'll only show ones that are available for countersink holes. Okay? Okay, I think I'm basically finished with the webinar itself. Just a little recap of what we showed over here. We showed the option, let me just close this. We showed the depth option inside our pocket operation, pocket recognition. We showed also how to work on fillets, multiple sides, and also working on the advantages of working with pocket recognition instead of pocket on complex faces with many open edges, as shown in this particular part over here. And of course, we went through our Hole Wizard, showed exactly how using our Hole Wizard. We showed also the option in our Hole Wizard of choosing a different database, creating more operations inside our recognition operations or machining processes inside our Hole Wizard process itself. We showed also that we've also added a little pin over here to keep it open. All of this is now available in 2016, and these are some of the new options, and that's basically it. If there are any more questions, yes, again, these parts will be available, and Eddie will have the link and send them out. So I guess that's basically it for now. Any more questions? I'm still open for questions. Okay, Eddie? I'm finished.
Hi, Sydney. Thank you very much for this interesting webinar, first of all, and for your effective efforts to promote this important model and to make it better and better with every version. Thank you. And to all our attendees, thank you very much for your patience today, for your time today, and we'll see you next week. It will be a webinar probably about DCAM, what's new there, tips and tricks with this Wirecut product. Thank you very much, Sydney.
All right,
Bye.
take care, everyone. Have a great weekend.